Okay, we would like to open it up now for the Q&A. So if you have any questions, please drop them in the Q&A box. We did receive some during the presentation, so I'm gonna go ahead and start asking the questions now, Kingo. So the first question is, what are the trade-offs with integrating the gate driver into the same package as the GaN device?
What is trade-off with integrated gate driver into same package? So I think it is asking about the comparison between SiP and discrete solution, right? Yeah,
I think so.
that's how I understand this question. So there's pros and cons, right? If you go to system in package product, so you can reduce how to say the parasitic inductance between gate driver and GaN. That means you can get higher efficiency. But if you the SiP, so gate driver is already there, so you can't switch or you can't choose your gate driver, right? So you lose kind of flexibility. So there's pros and cons between SiP and GaN, between SiP and discrete solution. So that's why we are offering both, like SiP and discrete solution. That way we can provide options to the customers.
Perfect. Thanks, Kingo. The next question is, where are our devices manufactured?
So this depends on which part number you are talking about. But so we have internal factory, and also sometimes we use outside. When I say outside, that is foundry service or OSAT. So yeah, we have both internal factory and outside factories, depending on the part number.
Thank you. The next question is TOLL versus TOLT advantages for top-side cooling. TOLT versus dual-sided cooling. Is there any advantage to double-side cooling package?
So from thermal performance perspective, so of course dual side cooling is better compared to TOLT, because thermal part, there are two thermal parts, right? Top side and bottom side. You can cool the device from both sides. So that's why dual side cooling is better than TOLT from thermal performance perspective. However, yeah, I think that is a big difference between them.
Awesome. Next question is, there are several GaN suppliers in the market now. How does ROHM differentiate from those suppliers?
So yeah, so let me go to here. So I think I have a good slide for that. So as you can see here, so ROHM is currently offering not only a GaN device, but also related IC products. So this is how we are trying to differentiate from other suppliers. If you look at, for example, supplier A, they only offer GaN device, right? But we propose total solution, right? So this is how we are trying to differentiate.
Awesome. Next question is, people admit that GaN device is a really good performance. What else is necessary to accelerate the GaN market expansion?
Okay, I think there are two important factors. One is pin compatible product, right? So some suppliers offer a very unique package, and then customers cannot find out second source to that. So having second source is really important from customers' perspective and from GaN market expansion perspective. And the second point is this slide, providing total solution to the customer. That way, customer can easily adapt a GaN solution to their applications. Yeah.
Awesome. The next question is, are there any plans to be automotive grade?
Yeah, so we are planning to be automotive grade in 2026. That is what I can tell you right now.
Okay. And then we have another question here. Which product does ROHM focus on? Discrete GaN product or module product, and why?
Yeah, so I think I gave you a little bit answer to that question in previously. So we are focusing on both because there is pros and cons, right? Module, it's easy to use because gauge driver is already there, but less flexibility in terms of gauge driver selection. So that's why we are offering module as well as a discrete solution. That way, customer can choose whatever they want. Yeah. That is our, strategy.
Awesome. And so we are running out of time, so Kengo only has time to answer one more question. The last question is, ROHM offers silicon carbide as well. How can silicon carbide and GaN coexist in the market?
So yeah, frequencies, switching frequency is different. SiC is here, GaN is here. The switching frequency is different. For example, there's good example. For example, if you look at electrical vehicle, so traction inverter application, that is for silicon carbide device because switching frequency is very low. But if we look at onboard charger in the electric vehicle, that is for gallium nitride because switching frequency is relatively high. So yeah, this is how they can coexist. The point is switching frequency. Okay.
Thank you so much, Kengo. So we did have some more questions, but we're running out of time, unfortunately. You can go ahead and email us and we can answer those questions to you. So thank you so much, Kengo, for your time today and everyone. And this presentation will be available on the demand landing page after the webinar. So yeah, thank you for your time and we hope you'll join us again for future webinars.
Thank you, everybody.